Hey everyone, welcome to CrickStacks. Today we're going to dive deep into the concept of merging arrays efficiently, and I'll also show you how to optimize for both time and space complexity in the process. So we'll be looking at the big O notation. I know that merging arrays might sound simple, but it can be tricky when dealing with large data sets. So let's break it down, understand what's happening under the hood, and find ways to make it faster and more efficient. So first things first, we'll start with the basics. Uh, let's say that we have two sorted arrays, and our task is to merge them into one sorted array. This is what it will look like. So first, we will create two arrays, array one, and let's say it's 1, 3, 5. And then we'll create another array, array 2, and we'll have 2, 4, 6. And then we need to merge those two. So let's create a merged array. And then we're going to take array 1. We're going to concat. Using the concat method, we're going to concat array 2 into it. And then we also needed to sort it, so we can use the sort method as well. If we just use the sort method like this, what JavaScript does under the hood is it'll take the arrays, array 1 and 2, and convert these integers into strings. And then it's going to try and compare the strings. So if you have like 15 and 5, those two numbers as strings, it'll tell you that 5 is larger than 15. So we don't want to do that. We want to pass the comparison function here. So we're going to be comparing A and B. Let's do function, and then we will compare A minus B. So what's happening here, the sort method is going to take two numbers, A and B, and subtract them. So if the outcome of these is a negative number, that means that B is larger. If it's a 0, that means that they're both the exact same number. And if it's a positive number, then A will be the larger number. So let's see what we get here. Console log, and then merged array. So I have this file. I'm in this directory, so I'm going to run node merge array.js. So here we got the sorted array. So far so good. We're using concat to combine the arrays and sort to make sure the result is sorted. But it's not the most efficient way, especially if the arrays are already sorted. Sorting a merged array from scratch includes unnecessary time complexity. So what's happening with the sort, it's taking the arrays and it's dividing them, like divide and conquer. It's splitting them in half until it gets to just one number. And then it's going to compare that number to the next number, and then it's going to merge. It'll create the new array to put them all in a sorted array. So instead of using sort, which the big O notation for this would be O M plus N for concatenating. So we're iterating through both arrays, M and N, which is array 1 and array 2, and concatenating them, merging them into another array. And then for the sort method, it's a log M plus N. So because it's recursively going and checking all the numbers. So we can merge the arrays in a much faster way, taking advantage of the fact that they are already sorted, right? So the goal here will be to get rid of this cat and sort, and we want to end up with O M plus N for the time complexity. So let's try and do that ourselves. We'll look at the two sorted arrays and we'll compare their elements step by step. So let's create a function, merge sorted array, and then array 1 and array 2. So we are going to go iterate through each array and compare the numbers ourselves. So we're going to have a pointer where to look. So we'll start declaring I equals to 0. We'll start from index 0, and then we'll do at j for the second array, but let's just do it here. J equals to 0. And then we also have to create another array, a merged array, for us to put those numbers into the new array sorted. But we'll initialize it to an empty array. Okay. So here, while we'll iterate through them, while I is less than array 1 length, and j is less than array 2 length. Gonna mess me up. Let me fix that. So while this is true, while I is less than the number of elements in the arrays, we're going to continue to check both arrays. So now we want to put, let's do a comparison. So if array 1 position 0 is less than array 2 in position 0 for the second array, that means that the number in the first array, position 0, is less than the second one. So on here, we would put array 1, index 0, into the merged array. So merge array, push. We're pushing array 1, I. And when we push that, we have to increment the I because we already checked position 0, index 0, and now we want to check the next one. So the opposite, if it's not true, then else we will do the opposite. We will add array 2 index j into the merged array, and then we'll increment j. So let's see what the outcome for this would be. Let's call this console log merged sorted array. And then here we're passing these two arrays. So array 1 and array 2. Okay. All right, I did something wrong. Let's check what I did wrong. Console. Oh, misspelling. Sure, none of you ever do that. Console log. Okay, let's run it again. And they're undefined. Oh, I'm not returning the new array. So let's return merged array. All right, there we go. So now it's sorted, but it only sorted up to 5. The reason for that is because while we're doing the while loop, we're incrementing I and j. So once it gets to the end of one of them, if there's something left on the other, it'll not run it. So what we want to do here is, if there's any elements left in either array, we want to add them to this merged array. So we'll do array 1 dot slice I, or we would concat array 2 slice j. So here we're slicing the rest of the array and only returning anything that's after this index, including the index. So let's save it. and run it, and now we get all the items. Okay, so by comparing each element in the arrays and merging them on the go, we achieve a linear time complexity of O of m plus n, which is what we were going for right here, which is much faster than sorting after the fact. Now let's talk about the space complexity. In our previous example, we created a new array merged with which required additional memory proportional to the size of the arrays, array 1 and 2. We were creating a new merged array. So we want to minimize the amount of additional space we use. And if we could merge the second array directly into the first, that would be ideal. So we have to assume that the first array, array 1, has enough space to hold all the elements from array 2. And then we'll also use a two-pointer approach to merge these arrays in place, starting from the end of both arrays. This way we will need extra space for the merged array. So let me comment all this out right here. So here we're assuming that the first array is large enough to hold all the elements, right? So we'll just create the first array with 6 spaces, and then these 3 will be able to fit at the end, but we're going to have to also sort. So how will we do that? Let's go to the bottom. Let's create a new function. So we'll merge in place, and here we're going to pass array 1, and then we also want to pass the number of elements for that array that we want to iterate through. So we'll do m for array 1, and then array 2, we'll do n. Okay. And here again, we're going to create the pointers. We're going to be starting from the end, so we'll use I for the first one, and this will be m minus 1. So basically, we're going to tell it, like, if this is array 1, we want to start at 5, so it'll be 3 items, 1, 2, 3, and then minus 1, which will give us the index of 2 to start there. And then same thing for the second one. Let j equals n minus 1. And we also want to do another one, k, for starting at the end of array 1 and start adding those sorted arrays to the end of the array. So we'll do m plus n, which is the two arrays, 6 items, minus 1. This will give us index 5. Okay, so here we start again with a new while loop. So we'll do while I, here it has to be greater or equal to, because we're starting from the end, 0. So we're going to be starting from 2, and then we'll start going down to the lowest number. So while I is greater or equal to 0, and j is greater or equal to 0, we'll iterate through all of them again. And we start doing the comparisons. If array 1 I is greater than array 2 j, mess this one up and clean it up. So if this is greater, we're going to put it at the end of the array. So we're going to put it on array 1, same array, oops, 1, but at index k at the end of the array. So we're going to do that equals array 1 I. So if this is larger than the number in array 2, then we're going to add this one to the end of the array. Else we'll do the opposite. Oh, I forgot. We got a I minus minus and array 1. We're going to add it array 2. So if this number is larger, we'll just add that one to the end, or to the index that we're passing here. And then here we would do j minus minus as well. And then once we do the comparisons, we add something to this index. At the end, we want to do k minus minus as well. So now we're looking at not the last element, but the one right before it. That's where we're going to add the next number. And then same as this one over here, if there are any remaining items in either array or in the second array, we want to add them to the array, to the beginning. So we'll keep iterating while j is greater or equal to 0. We will add array 1, k equals array 2, j. J minus minus, k minus minus. So if there's any elements left in the second array, we want to add them to the remaining spaces in the first array. So we have the array 1, 2, we have this. So now let's call merge in place. And we said we were going to pass array 1, and we want to iterate 3 items, and array 2, 3 items. And then we want to see what the output of array 1 is. Here we don't want to return anything because here we're passing array 1 and 2, and we're just updating array 1. So we don't need to return it because it's already available on the outer part. So console log, let's try this. And here it's sorted it. So by merging from the end, we avoid overriding values in the first array as we go. The great thing about this approach is that we achieve the same O of m plus n here. O of m plus n time complexity, but we now have reduced the space to complexity of getting a call. Okay. So the space complexity that we achieve now is O of 1. Because we aren't using any additional memory to merge the arrays. We're merging it into an already declared and initialized array of 6 items. So it's not taking up any more space. Now, if we were to start with array 1, like so, then the space complexity would be the O of m plus n, since JavaScript will automatically resize the array to fit the new data. In other programming languages like Java, you would have to create a new array to store all the data. Yeah, but JavaScript is flexible and will automatically resize your array, but will allocate more space in memory. So to wrap up, using concat and sort is simple but inefficient in large data sets. A more efficient approach uses the two-pointer technique to merge sorted arrays in a O of m plus n time. And to optimize the space complexity, we can merge arrays in place by starting from the end, achieving the O of 1 space complexity. So that's it for today. I hope you enjoyed this dive into the merging arrays and learned some new optimization techniques along the way. If you found this helpful, like, subscribe, and hit the notification bell. I'll be posting more things like this, some programming tips and tricks. So yeah, we'll see you on the next video.